In a previous assignment on buoyant force, there was a particular question that many of you had got wrong. So in this video, I'm going to explain how to do that question. But what I want you to understand from this video is how to approach those particular types of questions. So after this video, there is a similar question, and in order for you to be able to do that question, you need to pay attention in this video and understand the basic thought process behind such questions. So the question says a block of volume 0.05 meter cube is placed completely underwater. So let me draw the diagram quickly for this. Here I have a tank of water and this is my cube placed underwater, completely underwater, and its volume is 0.05 meter cube. Let's not draw an arrow right now because arrows are generally used to show the force, so I won't draw an arrow here. You should also avoid drawing arrow. I can just write it here just like that, and so I'll just write V equals this much, and rho, which is density of the block, so I can write rho B, density of the block, is given as 700 kg per meter cube. Also the density of water is given as, so I write that as rho W, the density of water equals 1000 kg per meter cube. So yeah, those are the things that are given to me, and the first thing that the question asks me is what is the volume of water displaced. So first of all, what you need to do is you need to visualize such kind of a situation in which you have a block being immersed in water completely. And what is volume? Firstly, volume is the amount of space that something occupies. So this particular block occupies 0.05 meter cube of space. So when I put this in water, I need to create 0.05 meter cube of space to accommodate this block. So this much amount of water has to move out of this space to create space for this, right? So this is the exact volume. So an equal amount of volume has to be displaced, right, of water to create space for this. So the volume of water that is displaced should be equal to the volume of the block, right? Because that is the volume or the space that I need to create to accommodate this block. So the first part simply says that the volume of water displaced is equal to 0.05 meter cube, because that is the volume of the block. Now what is the weight of water displaced? Okay, so the weight of water displaced. First of all, what is the mass of water displaced? Well, we know that density equals mass per unit volume. I know that the volume of water displaced is 0.05, so I can just put that here instead of my volume, and I get m upon 0.05. I also know the density of water. So because I'm finding the volume of water, I'll put in the density of water. Many of you were not visualizing the question and simply putting in numbers. So some of you were trying to put in the density of the block, some of you were trying this. So don't guess here, just think. If I have to find the mass of water and I'm putting in the volume of water, then I should put the density of water in here so that I get the mass of water, because I'm considering water right now, right? Because I have to find the mass of water. Now I can simply shift it on the other side and I get mass equals 1000 into 0.05, or rather mass equals 50 kg. 1 2 3, yeah. So I get 50 kg as my answer. So this is the mass of the water that is being displaced. Now to find the weight, I can simply multiply my mass with the gravitational acceleration, right? And so mass in this particular case is 50 kg, so I'll write that as 50, and gravitational acceleration, as you know, is a constant, which is 9.8, and if I do that, I should get 490 newtons. The unit of weight is newtons, right? So I get 490 as my answer, and this is the weight of water displaced. Now Archimedes principle, or the formula for buoyant force, which is given by Archimedes principle. So yeah, I missed this in the last module, but the statement that the statement of buoyant force, which says that the buoyant force on an object immersed in any fluid is equal to the weight of the water displaced by that object. So this particular statement is called the Archimedes principle. So it has a name, Archimedes. This is the name of the person who first discovered the this law of buoyant force and how to calculate it, and we call it the Archimedes principle. So by Archimedes principle, we know that the buoyant force on this particular block, which would act in this direction, would be equal to the weight of water displaced, and the weight of water displaced, which we just calculated, was 490 newtons. So this particular value here is the weight of water displaced, 490 newtons. Next, the question, so yeah, that is the C part, what is the buoyant force? And coming on to the D part, will the block float or drown? So how do I find? Well, there are a few number of ways by which I can find out if the block will float, or if will it, so it's already underwater, but will it remain underwater, will it remain sunk, or will it come up to the top of the water, will it start floating? So to find that out, what I can do is, I have a number of ways to find that out. So the first and the most straightforward method would be to look at the forces involved in this particular case, right? What are the two forces? Well, we have the weight which is acting downwards in this direction, and we have the buoyant force which is acting in that direction, right? So we have to find the net force on the object, and if the net force is 0, the object will stay where it is because we'll get no acceleration. If the net force is in this direction, or if the buoyant force is greater, it will start moving in that direction, and it will float, it will come to the top and start floating. And if this force, which is the force due to the weight of the object, so if the weight is greater, then the object will obviously sink, it will remain sunk. So first of all, let us find the weight of the object. So the weight of the object equals its mass times the gravitational acceleration. What is the mass of the object? Well, we know that density equals mass per unit volume. What is the volume of the block? Well, the volume of the block is given as 0.05 meter cube. So I can use that value here, 0.05. What is the density of the block? So here I need to put in the density of the block, because I am finding the mass of the block. So the density of the block is simply, it's given here as 700 kgs per meter cube. Now I can simply shift my 0.05 from here to that side. I'll just quickly do it, and what I get is 0.05 into 700 gives me the mass, right? And I can solve it. I'll just flip the equation this way. Therefore mass equals this thing. So 7 5 is 35. I have 2 zeros, 1 2. So yeah, I get 35 kgs. I hope my maths is correct. Yeah, so I get 35 kg as the mass. So this block here has a mass of 35 kgs. Now I can take this particular value and put it into this equation here. I'll just remove the extra things. So I'll take this 35 and put it in the place of mass here, because this is the mass, 35, right? So now I know that the weight of this block would be 35 into gravitational acceleration, and I know that the gravitational acceleration is, well, 9.8 meters per second. So the weight equals 35 into 9.5. Now that should be around 350. It'll be less than 350. It should be, I believe, 343 newtons. So that is the weight of the block here, right? So yeah, so I have found the weight of the block. So this 343 newtons is the force that is pulling it downwards, or the weight of the object, or the force of gravity which is pulling it downwards. Now let us find, so I'll just write this here at the top. The weight equals 343 newtons. Perfect. Now what I need to do is I need to find the buoyant force. Well, actually we found the buoyant force because the buoyant force on an object is simply the weight of the water displaced. And just now we found that the weight of the water displaced was, well, the weight of water displaced. So I'll just write it as the buoyant force, because this is the buoyant force, right? FB, the buoyant force, which is equal to the weight of the water displaced, and that was 490 newtons. Now clearly we can see that the weight of the block which is pulling it downwards is 343 newtons, and the buoyant force, which is also the weight of the water displaced, which is the force which is pushing it upwards, is 490 newtons, which is clearly greater than the weight of the block, and therefore this force wins the tug of war and it pushes the block upwards, and therefore the block starts moving upwards and it reaches the top of the surface of the water. It reaches the surface of the water and starts floating. So that is the simple logic behind it. And if I have to find the net force that pushes it upwards, we can simply subtract the larger force. So we can simply subtract the smaller force, 343 newtons, from the larger force. So the difference here is 147 newtons, and this is the net force that acts on this object. And now if I have to find the acceleration of this object, what I can do is I can apply Newton's second law. So let me remove this from here, and what I can do is I can apply Newton's second law to this object. Newton's second law states that force on an object equals the mass of that object times its acceleration, and this F here stands for net force, and the net force in this particular case is 147 newtons. So I can plug that in here. 147 equals the mass of the object, and we've just found that the mass of the object was 35 kgs, right? So 35 kgs times the acceleration. So I can simply shift this 35 on this side, obviously remove it from the other side, and what I get is, so if I write it in the next step, I can switch this equation this way, and I get that acceleration equals 147 divided by 35, right? And if I solve this, I get 4.2 meters per second square. So this is the acceleration of the block, and the block would obviously start moving in this direction with an acceleration of 4.2 meters per second square. So this was the basic thought process that you need to follow while solving such questions. And yeah, I think I have covered almost everything about such type of questions. And now if you've understood this thought process, you may move on to the question given in the assignment. If you still have any doubts, watch this video again, or you may ask me. That's it for this video.